Neo-ski. Everything starts with knowledge. Today we're going to be looking at data analysis. This is the first video in a short series that will be uploaded to this channel, exploring my personal experiences with data and how data is often manipulated and how it's presented and used in the scientific world. So let's first of all start by looking at what data actually is. So to do this, I'm going to be comparing data with information. Data, as you probably already know, is generally numerical, it can be statistical, it can be presented graphically, and it generally consists of facts and figures. However, information is data with context. So we take all of those numbers, all of those facts and figures, and add additional context to them, such as how the data was collected and how the data has been manipulated to fit into graphs. For example, this is a graph which shows the abundance of different chemical elements. This is an example of data. We're not given a great deal of context on this graph about what it's actually showing us and how the data may have been manipulated. Here is the context that goes with this graph. You can see that the abundance has actually been put into a logarithm of base 10, and that the abundance of silicon has been normalised to 10 to the power of 6. This is quite important information, as if we didn't have this and we read straight off this graph without the context, we could mistake different pieces of information, and our data would then not correspond to the actual values that were originally recorded. So, what about presentation styles? We've seen graphs already, but what about those initial tables and graphs? So, tables are easy to create, and it's the initial place where data is normally sourced. So when experiments occur, tables are normally the place where all of that data is recorded. However, skill is required to identify trends and patterns within data from tables, which is why we often use other presentation techniques to show those patterns, and I'll get onto that in a little bit. Tables can present an unlimited number of data sets, where data sets are different sets of data which present information about one item, say the melting point or the boiling point of an element. However, tables, as we know, they can be overwhelming. When you're looking at a table, it's not always clear what information it's trying to show. So, graphs show trends and patterns. Very, very ideal for doing that. However, those trends and patterns aren't easy to see once they've been plotted straight away. Normally, that data needs to be manipulated to show those trends and patterns on a graph. But graphs are easily readable once they've been plotted, but they show a limited number of data sets. Say, for instance, if you wanted to put the melting and boiling points on a graph, that would be relatively simple. They're both a temperature scale. But if you wanted to relate that to states of matter, your graph would get quite cluttered quite quickly, because states of matter is not a scale that fits into temperature quite nicely. Instead, it's just a word, a solid, liquid or gas, that aligns with your data. So, here is the table where our previous data has been sourced from. You can say it's quite overwhelming and there aren't any clear patterns. So what has happened is it's all been put into a log of base 10 and then plotted on this graph. Another way which we could show this data is with a bar chart. So that's the end of this video, and I hope that this little exploration of different data types, different presentation styles, and the difference with information has really been helpful. We'll be using all of the information in this video in our later videos, and you can see the project that this video is based on in the description down below. Thank you very much for watching, and remember, everything starts with knowledge.